You know, every single day, you and we trust dozens of devices to just work. But behind that sleek design, there's this invisible world of microscopic decisions, and it's all managed by a group of engineers you've probably never even heard of.
I mean, really think about it. Your phone, your car, your computer, they're all put together from thousands of individual, tiny little components. But who actually decides which resistor or which microchip gets the green light? Who's the person making sure it won't fail on you when you need it most?
Well, that person is the component engineer. You can think of them as the guardian of a product's fundamental building blocks. It's their job to make sure every single piece, no matter how small, is absolutely the right one for the job. So, what does that process actually look like? Let's dive in.
Okay, first up, finding the perfect part. Now, this is nothing like scrolling through Amazon. It all starts by taking your product's high-level design goals and translating them into a super specific set of requirements for just one single component.
This right here is basically the component's blueprint. The engineers have to ask all these critical questions. How much electrical stress can it really handle? How is it going to perform when it gets super hot or cold? Does it create any interference that's going to mess with other parts? And crucially, they have to plan for how the part will age. It's this thing called derating. Basically, they accept that a part will get weaker over time, so they build in a safety margin right from day one. And they don't just guess about this stuff. They rely on these incredibly rigorous industry standards. So for example, any part that goes into a car has to meet the Automotive Electronics Council, or AEC, standards for reliability, which are, as you can imagine, super tough. For other electronics, you've got global standards from organizations like JEDEC and IPC that act as a universal language, making sure a chip made in one country will work perfectly on a board made in another. But here's the thing, the technical specs, that's only part of the story. The engineer is in this constant balancing act, a three-way tug-of-war between cost, lifecycle, and reliability. The part's got to be affordable, it has to be available for purchase years from now for repairs, and it absolutely, positively cannot fail. Nailing this balance, that's the core of the job.
So, once a potential part is chosen, you'd think the hard part is over, right? Nope, not even close. In fact, the hardest part is just getting started. Now that component has to survive the gauntlet, a whole series of intense tests designed to prove it's worthy.
And this is the critical question, isn't it? A part can look absolutely perfect on a datasheet, but how is it going to behave in the real world under real stress? Well, that's where qualification and validation come in.
And believe me, this process is brutal. First, electrical validation makes sure it meets its specs. Then, it's literally baked, frozen, and soaked to simulate years of aging. It gets shaken and dropped to test its physical limits. And finally, it's checked for any electromagnetic interference to make sure it plays nice with all its neighbors on the circuit board.
And some of these tests are just unbelievably intense. For instance, a high-temperature operating life test, or HTOL, runs a part at extreme heat for 1,000 hours straight. This trial by fire basically simulates an entire lifetime of stress in just a few weeks. It lets engineers see into the future and prevent failures before a product ever even leaves the factory. Okay, so a part that survives the gauntlet is now officially qualified. Awesome. But getting it from the engineering lab to the actual factory floor requires one more absolutely critical step: meticulous documentation. You can think of all this documentation as the component's passport. It has everything: super precise drawings, the digital footprint so circuit board designers know exactly how to place it, and proof of environmental compliance. It also gets the part added to the company's Approved Vendor List, or AVL. That's the official VIP list of parts the factory is actually allowed to buy and use.
And let me be clear, this is not just boring paperwork. Without this passport, disaster is just waiting to happen. A factory might accidentally order a slightly different version of the part, maybe one that's just a millimeter off, and that tiny mistake could lead to an entire production run of faulty devices. We're talking millions of dollars down the drain.
But a component engineer's job doesn't just stop when the product ships. You think they could finally take a break, right? Wrong. They are also responsible for guarding that product against future problems, especially the constant threat of supply chain disruptions. This is what we call the long watch. These engineers are constantly tracking notifications from suppliers about tiny changes to a part, or even worse, if a part is being discontinued altogether. They're monitoring the financial health of their suppliers to make sure they'll still be in business in a few years, all to proactively manage the risk of a key component suddenly vanishing. Because when a part does become obsolete, the stakes are just enormous. The dream scenario is finding a drop-in replacement, a totally different part that works perfectly without needing any other changes.
Finding that one part can save a company from a massive, super expensive, and time-consuming product redesign.
But what happens if there is no drop-in replacement? Suddenly, the original trusted part is just gone. This is a 5-alarm fire for a manufacturing line, and it opens the door to a very, very dangerous world.
And the choice becomes really difficult. Do you wait and hope the original supplier eventually makes more, or do you turn to a broker? Now, brokers often have the part you need, but there's a huge risk it could be a counterfeit or maybe a refurbished part that was pulled from some old scrapped electronics.
So to navigate these really risky waters, the component engineer basically has to become a detective. They perform audits on potential brokers, they run a whole battery of tests on any parts they buy from them, and they make sure to be totally transparent with customers about where these components are coming from. It is all about managing that risk.
So, after all that, why does this all matter so much? It's because the component engineer is the crucial, often invisible link that holds the entire product chain together. Just try to wrap your head around the scale of it. A single product can have thousands of individual parts. That means thousands of decisions were made, and thousands of risks were analyzed and managed, all to make sure that the final product in your hand works exactly the way you expect it to. Ultimately, they're the essential bridge. They connect the brilliant vision of the design engineers with the harsh reality of the supply chain and the incredible precision needed on the manufacturing floor. Without them, the whole thing just falls apart. So the next time you pick up your phone or start your car and it just works, maybe take a second. Think of the component engineer, that unsung hero, the guardian who stress-tested, documented, and defended every single tiny piece that makes it all possible.